Hey guys, I thought I would share a project today. It's called Retro 2, and it's an Apple II compatible computer I made. I've been working on it for about a year, and it's made with all off-the-shelf parts. So you can build this with parts you can find today that are still in manufacturing. And it was kind of inspired by the 8-Bit Guy and his video that I watched about a year and a half ago that was about his dream computer, and it got me thinking about what my dream computer was. And my dream computer really was the Apple II when I was growing up. It was really easy to learn, and simple graphics, bitmap graphics, just really friendly. You turn it on, you could start programming in BASIC right away, and just very simple computer. But the simplicity and the constraints of the computer really made it fun to program and made you be creative. And it's really what got me started being interested in computers and in programming in general. I'm not very good at this game, obviously, but so it was the nostalgia, and it was partly David's video and just wanting to create something for this generation of kids that there's tablets and there's phones, but I think part of the beauty of computers like the Apple II and the Commodore 64 and ones that I grew up with was that they were simple, and you could actually look at the components and see that how they worked, and so that was part of the reason that I wanted to create this computer. I called it Retro 2 because it came after Retro 1, which was my first 6502 based computer that I came out with maybe 5 years ago. So, see, what else can I say about this? It's smaller than the original Apple II. It's about 9 inches by 13 by 3.5. I can show you. Actually, I can kind of show you a little bit more what the computer looks like. So, obviously, it kind of looks similar to the Apple II. It's just an acrylic case that I had designed, and I got this little keyboard from Amazon to fit on that. I have, let's see, different colors. I don't know if this is going to show. There's blue. There's like a light blue. There's red, purple, yellow, white, and then green. I have a debug screen, so you can see I'm at about 50 frames per second, and this is my clock speed. I can actually speed up the clock if I wanted. See, it goes a little bit faster. Whoa! I can even slow it down until things are about basically stopped, 0. Speed that back up. I have my soft switches over here, so you can see high res is on. page 1, and let's see what else. Let me show you a little bit more about the sides over here. I don't know if you can see it. I have the Karateka guy kind of engraved. It probably doesn't show up very well. Right over here, into the side of the case. I've got an SD card for storage right there. A PS2 connector for my keyboard, VGA, on-off switch obviously, and a 12 volt supply. So you can see I have the 6502 is back here. Maybe I'll take the monitor off. So I made it so this top can kind of lift off really easily. It has a little slot to keep it from moving up there. So inside, you can see here is one parallax propeller. Here's another. Here's a 6502. My ROM. Oops. My ROM's right there. This is all address decoding, so I can support the Apple II addresses. Here's the second parallax propeller back there, and it's hooked up to my dual port RAM chip, static RAM. And basically this propeller back here is in charge of getting keyboard data, reading keyboards, and sending that to the data bus, as well as getting the soft switches, and it sends the soft switch settings over to this propeller, which is in charge of reading the video RAM and creating the VGA signal. This propeller is also connected to this SD card, so I can load Apple DOS games and basic games into the RAM and play those. What else? They're connected via I2C, so those two propeller chips talk via I2C. And this propeller, originally I had the clock based off of this little oscillator right here. It's a 1 megahertz oscillator. But then I have a jumper, actually the jumper's over here, that you can set. If you have this jumper in here, basically the propeller can then generate the clock signals. So that's what enables me to have the from 0 to 3 megahertz clock, and I could go higher than that if I wanted, but it seemed like around 3 or 4 megahertz was the max that the programs would run at for this computer anyway, so at least reliably. What else? Alright, so I went over that side. Let me look at this side here. So over here we have 4 joystick controllers. These over here are the original 9-pin joysticks from the Apple II, Player 1 and Player 2, and then I have 2 game port controllers, the 15-pin game ports for Player 1 and Player 2. I have a headphone out jack if you wanted to connect headphones. I have a volume knob, which is kind of nice if you're playing at night and you wanted to not have super loud sounds. There's a built-in speaker. I've got cassette out, cassette in, so I can load programs via cassette or smartphone or whatever nowadays. There is my choplifter, little choplifter helicopter. Thought it'd be cool to have that on the case, and it's actually really neat. I'll show some shots of it at night, it actually, this little power LED will actually make this Choplifter logo glow at night. You can kind of see it's like, you can hear it's like bouncing off the edges of the acrylic. So back here I have 8 expansion ports that are compatible with the original expansion ports for the Apple II. And let's see, what else can I show you? Let me put my case cover back. Just snaps in place like that. Alright. So if you remember the Apple II, one of the cool things I liked about it was that when you first turn it on, you'll notice that beep sound, and you're presented with a cursor. Basically you're in AppleSoft Basic right now, so you could actually, oops, you could type in the program right into the console here. Right? So this is the one everybody uses to test this type of thing, but you can kind of see the idea. Oops. Let me list that. Right? So that's pretty cool. Computers nowadays, when you start them up, you know, it's not quite that easy to get into a programming console to create games. So that was kind of one of the features that I really thought was cool about the Apple II. I remember when I was growing up. So I could create a new program, and we'll do the one that generates the maze. Let's see. Okay, so this is kind of that program that the 8-bit guy uses that generates the maze. So you can kind of see this is it running at, oh, we're actually at 2 megahertz right now. Okay, so this is it running at the normal default clock speed, which was actually a little bit over 1 megahertz for the Apple II. But you can see I can increase the clock speed and it'll actually start running a little bit faster, and I can even slow down the clock, and that's kind of interesting. I can stop it as well. Okay, so now that I have the program entered, what if I want to save it using my cassette interface? So what I did is I have a headphone jack with a splitter, you can see, so that the microphone from my phone here is actually going into the output jack from the computer, and the input, cassette input, is going to the headphone jack. And I have an app that I installed. It's just called Voice Recorder. It's kind of cool. It has this kind of old school cassette interface so that I can pretend that I'm using an actual cassette, but you can go, I'll type save, and then over here I'll click record. That'll start recording. I'll hit enter. Okay, so it should be saving right now. Alright. Takes a few seconds. Okay, so that should be saved. I'm going to click stop. Alright, now I'm going to turn off computer just to clear all the memory. I'll restart it. Okay, so nothing is loaded into memory. I'm going to go load. Here. And then over here, I'm going to click play. Hopefully, if everything works. Should see something. Alright, a beep is good. Okay, so let's list it. Alright, there's my program. I can run it, and it still runs. So that's kind of cool. That's one easy way to save and load programs. So something else that I built in is I built a RAM monitor out of Spin, the Spin language that's running on the Parallax propeller. So if I click F3, it gets me into this monitor where I can type in an address or a range of addresses that I want to view or modify, and you can see I can read from text page 1 video memory right now. So this is reading memory parallel to the program that's running right now. Right, this is running Apple II program, and I can kind of thanks to the way the propeller works, I can do a lot of things in parallel. So I can go to my memory monitor, and you can actually look at program memory while it's running, which is kind of neat, and you can modify it as well. The other thing I have is if I hit F6, I can read from my SD card, and these are all Apple DOS 3 to 3.3 disk images that I can read from. I can scroll through. You can see I have 2 pages right now of disks, and to select one, say I wanted to go, I don't know, Pac-Man. So I want disk 3, and I can either load it by pressing L or R for run. I'm going to run program 2. And so what that's going to do is first it's going to clear the memory space, then it's going to do a reset and send the contents from the SD card through the first Parallax propeller and through the I2C into the RAM space, the dual port RAM. And this is something area I could probably optimize a little more eventually. It gets a little complicated because you're pulling from the SD card through I2C to the other propeller or into RAM, so it's kind of there's a lot of steps involved right now, but you can see I loaded Pac-Man into RAM, and then use my joystick. I can hide the debug screen if I want. Alright. But that's how you, that's how that works. And I'm not very good at Pac-Man, so probably die pretty quickly. Alright. It's just to give you an idea of how that works. The frame rate is pretty good with high res, and it's because high res is actually I used whoa, killed that guy. Assembly. It was written basically all in assembly in order to get 50 frames per second, and you could actually go a little bit more than 50 frames per second if I wanted to, by using a few more cores from the propeller, but it seemed fine to me. So I was pretty happy with how that turned out. Okay, so if you wanted to load a basic program, it's pretty similar to the way you would load the DOS program. So I click on F6 to get my listing here of disk images, and then say I wanted to load this two-line games disk image, so I would go disk 6, and this is from the Facebook group, actually the Apple enthusiast Facebook group. They had a two-liner contest, and so these are all from that contest, and they're pretty cool. One of my favorites is this Mind the Gaps. Alright, so I want to run 12. Alright, so it's similar to how it loaded the DOS games. It's going to download that, and then it gives you some instructions. So I'm going to press F4 and then type run. Press enter. Alright, so F4 gets me back to my video, and I'm just going to actually list the program first. So here's the listing. You can see it fits in 2 lines of code, which is pretty impressive. Go run. Alright, so here's the other thing I wanted to show. Like, you can see a little bouncy ball, but it's supposed to be in mix mode, and for some reason with basic programs, I haven't figured this out yet, but sometimes it doesn't always toggle the mix mode soft switch. So I actually have a way I can bypass the soft switches. I can actually toggle them manually. So for instance, here's the if I go function F1, so now you can see I have mix mode text down there, and this game it's kind of fun. You press the joystick button. Alright, now you go over. I'm not very good at it, but oh, there you go. So I made it 114. That's not too bad. But that is how you load a basic program. Alright, so I loaded up Choplifter to show one other kind of neat feature. You can see with the debug window here that sometimes I know I've kind of wondered how the game designers create these fluid animations, and just how do they get some of the cool effects in these games. And so you can see Dan Gorlin, the creator of Choplifter, he's actually flipping between page 1 and page 2, as you can see. He does that really quickly for every frame, and if I slow down the clock, you can see him every frame he's basically switching the page of high-res memory, and so that's kind of neat. You can even stop the clock if you wanted to, just to see, and manually go to page 1. There's page 2, page 1, page 2. We could go a little bit further. You can see. So that's kind of cool. Just another way you can kind of see what's going on behind the scenes of some of these programs that are running. Let's see, let me turn down the volume here. So you can see I can turn the volume all the way off, or I can, so you guys can hear me. Anyway, thank you for watching. This has mostly just been an overview of the system. I'm hoping at some point to make a more technical video. Anyway, thank you, and please make sure to subscribe. I also have my GitHub page for this project in the notes, as well as the Hackaday link. So anyway, thanks again for watching, and I'll talk to you later.